Welcome, my dear sixth grade students. I'm Mr. Ahmed Magdy, your math teacher. Our lessons today are the second and third lessons of the fourth unit of the sixth grade curriculum of the academic year 2024-2025. And this unit talks about equations and inequalities. We talked in the previous lesson about the definition of equation and how to solve it. And today we will talk about the concept of inequalities and how to express them, how to use them in our daily situation, then how to solve inequalities and find the values to satisfy them, whether in the set of integers or rational numbers. We will solve many examples of today's lesson because it's very important and will be repeated with us again in the coming stages. So we must understand it very well from now on. Okay, so let's go. The first part with us today is the definition of the inequality, its forms, how to express it, and how to use it in our daily life situations. Okay, so in this example, he says the opposite sign shows the speed limit for a road in kilometers per hour. Record all speeds that are acceptable to drive on the road. Okay, the sign here says the speed limit is 50 kilometers per hour. What is the meaning of that? It means that cars cannot pass this speed limit. So the maximum speed on this road is 50 kilometers per hour. And any one cross the speed limit will be punished. Okay, so the maximum number of kilometers per hour is 50 kilometers. Anything less than 50 are acceptable. Anything less than 50 is acceptable to drive on the road. Okay, so I have many choices and I want to find which speed is acceptable to drive on the road. The first one here is 23 kilometers per hour. Is that acceptable? Yes, because it's less than 50. Okay, so the first one here is acceptable. Next, I have 90 kilometers, and I think 90 is more than 50, so it's not acceptable. The third one, I have 50, so maybe it's acceptable or not acceptable. But the speed limit here says the maximum number of kilometers per hour is 50, so 50 is acceptable. So I can say the third choice is acceptable. Here I have 60 kilometers per hour. It's more than 50, so it's not acceptable. Next, I have 40 kilometers per hour, and I think 40 is less than 50, so I can say 40 is acceptable. And 55 is more than 50 kilometers per hour, so it's not acceptable. So I have three values here which acceptable to drive on the road. Okay, so this example tells me that all numbers that less than 50 kilometers are acceptable on that route. Okay, so if I want to express that situation in inequality, how to do it? Okay, I can represent that by using variables and the signs of inequalities. But what is the signs of the inequalities? The inequality is a mathematical sentence that contains the signs bigger than, less than, bigger than or equal, or greater than or equal, and less than or equal. Okay? Again, this is greater than, this is less than, and this is greater than or equal, and this is less than or equal. And any number that makes the inequality true is a solution of the inequality. Okay, so let's look on the previous example again. What is the inequality that expresses the situation? I want all numbers that less than 50. So I can say numbers like x, and x is a variable, okay, will be less than 50. So 50 is a bigger one. But here I have that 50 is acceptable. So I can say that x is less than or equal 50. Okay? Again, the speed limit here says that 50 is acceptable. So I can take 50 with us in the solutions of the inequality. Okay? So I can say x will be less than or equal 50. Okay? So this is the inequality that expresses the situation that's on your eyes right now. Okay? Next, I have an example like this. The sign shows the sale prices of some clothing on a sale rack. Okay? Use the sign to determine any prices you might expect to pay for an item from this rack. Okay? And record all prices that apply. The first one here is 70. Next I have 80, 100, 40, 20, 265. The sign here says starting at 75 pounds. Okay? So the minimum value or the minimum price is 75. So I cannot sell or I cannot buy anything that less than 75. Okay? So there is no price less than 75. Okay? So I want to record all prices that apply that condition or stipulation here. Okay? So I want all prices that more than or equal, because I starting with 75. So 75 is with us. So I want all prices that more than or equal 75. So I can express that situation in an inequality like this. I can say x is more than or equal 75. Okay? So I want to record all prices that apply this inequality. Okay? The first one here, 70. 70 is not more than 75, so I cannot choose 70. 80, yes, because 80 is more than 75. 100, yes, 100 is more than 75. 40, no, 40 is less than 75. 20, no, because 20 is less than 75. 265, yes, because 265 is more than 75. So I have prices that applies the inequality is 80, 100, and 265 pounds. Okay, let's do another example. He says the sign shows the height limits for an amusement park ride. Okay, so he says list 3 acceptable heights for a person to be able to ride the roller coaster. Okay, and number 2, list 3 unacceptable heights for a person to be not able to ride the roller coaster. Okay, the signs here says more than or equal 120 centimeter, yes. Less than 120 centimeter, no. Okay, so I would divide my solution into two parts. The first one is I want the values that more than or equal 120. And the second one, I want all values that's less than 120. Okay, so the first inequality is x more than or equal 120, and the second inequality is x less than 120. Okay, so I want 3 values here and I want 3 values here. So the first one, the second one, the third one. I know that I have infinity number of acceptable heights and I have infinity number of unacceptable heights for a person. Okay, so the first one here, I want 3 numbers that more than 120, so I can say 130 or 140 or 180 or 120. So 120 is with us in this inequality. Okay, but here 120 is not with us in this inequality. Okay, so I can say the first one here will be 110, maybe 105, maybe just 100. So I have here 3 values which are unacceptable heights, and I have here 3 values or 3 heights that are acceptable for a person to be able to ride the roller coaster. Okay, so I have 3 values here for the second inequality, and I have 3 values here for the first inequality. Okay, I have 2 examples like this here. The first one says Ahmed needed to earn at least 50 pounds to buy a scooter. Find 3 possible amounts that Ahmed needed to earn. At least means I want 50 pounds or more. So I cannot earn less than 50. Ahmed cannot earn less than 50 pounds. Okay, so I want values that may be more than 50 or equal 50. Okay, so our inequality here will be that x, the amount that Ahmed needed to earn, I want x to be more than or equal 50 pounds. Okay, so the 3 possible amounts may be any number that more than 50. So I can have 50 pounds, 60 pounds, 70 pounds, 100 pounds, 150 pounds. So I can describe or have many solutions or many amounts or many numbers for the inequality x more than 50. Okay, so Ahmed can amount 50 pounds, 60 pounds, 70 pounds, 100 pounds, 200 pounds, 150 pounds in a day. Okay, next he says write 2 possible solutions for each of the following inequalities. Okay, the first one here says x less than 10. So I want 2 values or 2 solutions for this inequality. I want 2 numbers which are less than 10. So maybe I can say 9, 8, 7, 6, 5, 4, 3, and so on. All of these numbers are solutions for the inequality x less than 10. Okay, here I have y more than or greater than or equal 3, greater than or equal 3. So I can say y equals maybe 4, maybe 3, because I have here the equal sign. So I can say 3 is acceptable. Okay, 3 is a solution for the inequality. Okay, so maybe I have 5, 6, 7, 8, and so on. So I'm starting with 3 and I have no end. And here I have 9 and I have no end. Okay, next I want to solve the inequalities in the set of integers. And we learned about the integers that we have positive numbers and negative numbers, but I don't have decimals and I don't have fractions. Okay, so integers is maybe 0, 1, 2, 3, 4, 5, and so on, and -1, -2, -3, -4, -5, and so on. This is a set of integers. Okay, so if I have an inequality like this, I have x more than -2, and I wanted to represent the solutions of the inequality on the number line. So I will starting with -1 because -2 is not with us in the solutions of the inequality. Okay, so I will start with -1, and after that I have 0, 1, 2, 3, 4, and so on. So I will select every integer that maybe can express or maybe can be a solution for the inequality here. So I can say -1 is a solution, 0 is a solution, 1 is a solution, and so on to positive infinity, okay? Because I don't have an end for the solutions here. But remember, -2 does not belong to the set of solutions for the inequality because I don't have the equal sign here. But if I have an equal sign like the second one here, x is less than or equal -1. So I will start with -1 because -1 with us in the solutions of the integers of the inequality, okay? So I can say -1 is the smallest solution or the biggest solution. -1 is the biggest solution, okay? And after that I have -2, -3, -4, -5, and so on. So the starting point here is -1 and I don't have an ending point. And remember, -1 belongs to the set of solutions because I have the equal sign here in the inequality, okay? So if I want to solve the inequalities in the set of rational numbers, here I cannot represent the solutions on the number line, okay? So I can say I will have possible solutions, but I cannot represent the solutions on the number line, okay? So if I have an example like the first one here, x is more than -2, so I will select or choose any number that bigger than -2 to be a solution for that inequality, okay? So I have here -1.5 is more than -2, -1, negative 0.3, 1/2, 1 and 2/3, and so on. All of these numbers, all of these rational numbers are solutions for the inequality x more than -2, okay? Here, the second one here, I have x less than -1. In the set of rational numbers, we can say a lot of numbers that can be a solution for the inequality. So I have here -1, and I'm starting with -1 because I have the equal sign here, okay? So I have -1.3, -2.1, -3, and 1/2. All of these numbers can be solutions for the inequality of x less than -1, negative x less than or equal -1, okay? So if I have two inequalities like this and I want to name three solutions in the set of integers of each inequality, then I want to graph each inequality on a number line. The first one here, I have x less than -2, okay? So the first one here, I will start with drawing as a number line like this. So I have here 1, 2, 3, 4, 5, and here I have 1, 2, 3, 4, 5. So I will write 0 like this, and here I have 1, I have 2, I have 3, and here I have -1, -2, -3, -4, -5, -6, okay? The first one here, x less than -2. So what is the minimum or the maximum number that can be a solution for the inequality? Okay, I want a number that less than -2. So the first one number will be -3. Okay, so the first solution for the inequality is -3. And after that I have -4. Next, I have negative 5. Next, I have negative 6. So all of these numbers can be a solution, and so on, because I have numbers less than negative 6. So the solutions will be negative 3, negative 4, negative 5, negative 6, and so on. This is the first inequality. The second inequality here is C more than or negative 4. So I will draw the number line like this. Okay. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and here I have 1, 2, 3. So I will start with 0 here. Next I have 1, 2, 3, 4, 5, 6, 7, 8. Okay, and here I have negative 1, negative 2, negative 3. I don't have any negative numbers because C here is more than or equal 4. So all of my solutions here are positive numbers. Okay, and the starting number here, or the minimum number here, or the minimum solution for the inequality here will be 4, because the inequality here says that C is more than or equal 4. So I want 4 and more. Okay, so the first number here is 4, and I want number that more than 4. So the next number will be 5. Next I have 6. Next I have 7. Next I have 8, and so on. All of these numbers can be a solutions for the inequality C more than or equal 4. Okay. Okay. Next, I wanted to name 3 solutions in the set of rational numbers. Listen carefully. I want 3 solutions in the set of rational numbers. So maybe the solutions will be decimal numbers or fractions, okay, for each inequality. The first one here, x more than negative 1, okay? But listen, here, x more than, not equal to negative 1. So negative 1 is not with us in the solutions of this inequality. Okay, so I can say x maybe equals negative 0.5. Okay, because 0.5 is more than negative 1. Maybe x equals 0. Maybe x equals 1/3. Maybe x equals 10. Okay, all of these numbers, all of these rational numbers can be a solution for the inequality x more than negative 1. Okay, next I have m less than 2. M less than 2. So I want rational numbers. I want the rational numbers that less than 2. So maybe I have 1.8. Okay, maybe I have 0.3. Maybe I have 1/2 or negative 1/2. Maybe I have 0. All of these numbers can be a solutions for the inequality m less than 2. Okay, but 2 is not with us because I don't have the equal sign here in the inequality. Okay, next I have the number line and the solutions for the inequality, and I want the original inequality. Okay, so he says here, write the suitable inequality that's represented by the following number line in set of integers. Okay, so the first one here, he starts with 0. Next I have 1, 2, 3, 4, and so on. Listen to me. Here I have two solutions or two inequalities that can be represented on the number line like this. Okay, so I have two solutions here. The first one is the inequality will be more than or equal 0. Okay, so I can say x is more than or equal 0 because I start with 0 and I have numbers that more than 0. Okay, or maybe I can say that I have the inequality says x more than -1. Why? Because I starting with the next number of -1, or the number that after -1, or the number that more than -1. So I starting with 0, next I have 1, 2, 3, and so on. So I have two inequalities here. The first one is x more than 0, or maybe x more than -1. The first one, x more than or equal 0, and the second one is x more than -1. The second one here, I starting with -2. Next I have -3, -4, -5, and so on. So I have numbers that less than -2, and I have also -2. So I'm starting with -2, and after that I have numbers less than -2. So I am decreasing. So I will use the sign of less than or equal because I'm starting with -2. So I will say that x is less than or equal less than or equal -2 because I'm starting with -2 and decreasing or maybe I am starting with -2 because I have numbers that less than -1, but I don't have -1 here because I'm not having the equal sign in the inequality. So I can say here x is less than -1 because I'm starting with numbers that less than -1, but I don't have -1 in the solutions of the inequality. Okay, so I have two inequalities here that can be represented by the number line. Okay, number 3, I'm starting with -3 and I am decreasing. Okay, I have -4, -5, and so on. So I have two inequalities. The first one is x, and I am starting with -3. So I have -3. And next, I have the numbers that less than -3. So I will say the inequality says x less than or equal, because I'm starting with -3 and after that I am decreasing. So -3 is with us in the solutions of the inequality. So I can say x is less than or equal negative 3. Or maybe I can say that x is less than negative 2, because I am starting with numbers that less than negative 2, but I am not having the negative 2 in the solutions of the inequality. I don't have negative 2 here, so I'm writing negative 2, but I am not equal to negative 2. I will not write equal to negative 2. Okay, this next one here, I am starting with negative 2, and after that I am increasing, so I have the numbers that more than negative 2, or maybe more than or equal negative 2. Okay, so I will say x is more than or equal negative 2, because I have negative 2 in the solutions of the inequality. Okay, or maybe x will be more than negative 3, because I have all integers that are more than negative 3, more than negative 3, but I don't have negative 3 in the solutions of the inequality. Okay, so our two inequalities, x more than or equal negative 2, or x more than negative 3 or greater than negative 3. Okay, next I have some examples like this, and I want to solve it. The first one, the inequality that represents values less than 2, less than 2. Okay, so I want the inequality. Okay, I will say x less than 2, so x is less than 2. Okay, next, the inequality in more than or equal 3 in mathematical form. Mathematical form like this way. Okay, so I have n, I have 3, and I want n to be more than or equal 3. N more than or equal 3. Okay, so this is the mathematical form for this sentence. Okay, next, the smallest solution of the inequality n more than or equal negative 4. Here the solutions starting with negative 4, but negative 4 is the smallest one or the greatest one. N is more than negative 4, so I want numbers that more than negative 4. So next I have negative 3, negative 2, negative 1, and so on. Okay, but I want the smallest solution. So the smallest solution will be negative 4. Okay, because I'm starting with negative 4 and I want all numbers that more than negative 4. Okay, next he says Amal needs 300 pounds to pay pants. If she does not have enough money, then the three possible amounts of money Amal has is what? Okay, I want three possible amounts of money that Amal has. Okay, Amal needs 300 pounds, but she does not have enough money. Okay, so Amal has what? Maybe she has 200 pounds. Okay, maybe she has 290 pounds. So I can say Amal maybe has 200 pounds, maybe 250, maybe 290, maybe 100, maybe 150. Okay, so all of these numbers can be a solution for this situation, but I wanted to express that in an inequality. So what or which inequality can be represent this situation? So I want numbers that less than 300, but I don't need 300, so I will not write or use the equal sign here. So I can say the inequality is x more than or less than, no, it's less than 300. So I will choose any three numbers, and these three numbers will be the amounts of money that Amal has. Okay, next he says Yusuf read at least 4 books. Use b more than or equal 4 to find 3 possible numbers of books that Yusuf read. Okay, first I am dealing with the set of integers because this is number and the number of books, and number of books cannot be represented by a decimal number or a fraction. Okay, so I want 3 possible integers to be the solutions of the inequality. So I have b more than or equal 4. So I want 3 integers to be more than or equal 4. So maybe the number of books is 4 because I have the equal sign here. Maybe b or the number of books is 5. Maybe the number of books is 6. Okay, maybe 7, maybe 8, maybe 9, maybe 10. Okay, so I want all integers that more than or equal 4. More than or equal 4. Okay, thus we have finished our video today, in which we explained the second and third lessons of the fourth unit of the 6th grade curriculum, and we understood the meaning of inequalities and how to solve it in different groups or sets of numbers. I hope you enjoy this video a lot because it's very important in our curriculum, and it will be repeated with us again in the coming stages. So see you soon in a new video and new lesson. I'm Mr. Ahmed Magdy, your math teacher. Goodbye.